Hi, I hope you completed the exercise in the previous lecture. Right now, within this lecture, I'm actually going to show you the solution of that exercise, and we're going to talk about multi-qubit states a little bit more so that we can just go along and start the next section. So remember cat 0 over here. So what was the cat 0? It's 1 0, right? So if we get the tensor product for cat 0 and cat 0 together, let's see what we have over there as a result. So remember how we do the tensor product. First of all, we need to just take the A, or the first element of the first matrix, and just multiply it with the second matrix, and so on and on. Okay, so we're gonna just multiply everything together and just write it into a single matrix, and that is cat 0 0, as you can see. So that's how we build this two states or two cat notations together. So once you see something like that, it means that you're gonna have to do a tensor product, not a regular matrix multiplication. So let's go back over here. So remember what we have talked about. This is cat 1 and cat 0, and by this time I believe you are familiar with them. And the thing over here is that this represents the probability of being 0, and this represents the probability of being 1. So what happens if we expand this into 2-qubit states? What does it represent? Okay, because in here at the left hand side, it's also P0 and P1. So we know this is the probabilities, but how it's working over here? So it's actually the same, it's the same logic. So this one is actually the P0 0. Okay, so probability of being 0 0. So this one is actually the probability of 0 1. And it goes like this. So this one is probability of 1 0, and the latest one, this one over here, is the probability of 1 1. So it's again the same logic. So if you look at the 0 1, cat 0 1, or cat 1 1, let's look at the cat 1 1. As you can see, the probability of being 1 1 is 100% at this point. So that's why we call this cat 1 1. And over here like that. So it all adds up. Okay, so whether we have 2 qubits or 1 qubit or multiple qubits, much more than 2 qubits, it will just be the same logic. We're gonna have to do the tensor product, we're gonna have to just adjust the probabilities accordingly, and it would be fine. For example, we're gonna see a lot of situations like this. We're gonna write cat 0 0, cat 0 1, so we're going to apply some gate into cat 0 0, and it will be converted into cat 1 0 or something like that. Okay, so rather than writing the whole matrices together, we can just write it with the cat notation. So we're going to use this a lot, but we're not actually going to deep dive into the cats immediately. We're going to see the matrix multiplications and other operations first in order to understand the background a little bit more. So over here what we see is a 2-qubit state with 1 and 1 over square root 2 and 1 over square root 2 at the P11 as well. So this is like a column matrix or a vector that represents the superposition and entanglement. Why? Because in the P0 0 state we have possibility of 50%, 1 over 2. So in the P01 state over here, we don't have any possibility, like 0%, and it's the same for P10, it's 0%, and for the P11 we again have like a 1 over 2 50% possibility. So what does it tell us? So we are in a superposition, and as you can see, we can always get 0 0 or 1 1 with 50% chance, but also we have entanglement as well, because it's either going to be 0 0 or 1 1. So remember, it has some kind of correlation between them. So we talked about electrons can be only spin up and spin down, like once you measure them, if they're entangled. And over here we can actually have two things at the same time, like 0 0 or 1 1, and we can represent this matrix with only this notation, cat 0 0, cat 1 1 added up together, with 1 over square root 2 coefficient. Okay, so if you see this, then you should know we are dealing with a superposition and entanglement for 2 qubits. So again, these are all just notations. We are going to do these operations in a much better way so that you can actually do the operations, you can actually calculate the results, and you can see the result for yourselves. But eventually we're gonna need to just simplify this by introducing cat notations in our calculations. So that's it. Now it is time to move forward, so see you in the next section.